Hi, this is Norbert with the Game Quarry and GQ Audio, and this tutorial is working with Rollerball again. It's doing all the things that we had it doing in the last lesson, and something that you may have noticed if you've been following along is that as the ball moves around the perimeter of this space, it bumps into the walls, but there's no sound, and there really needs to be a sound there. Expect to hear something since we're getting a sound for the pickups. So that's what we'll do in this lesson. We'll add a sound for each of those wall impacts, and then we'll also make some changes in FMOD so that those specific sounds will make sense given the collision. A hard impact will make a hard sound, soft impact a soft sound, and so on. If I switch over to FMOD, there's this wall hit event. This is a really basic event. Just plays a simple impact sound, no parameters, nothing fancy going on with this one whatsoever, and this is fine for what we need right now. You'll notice that a lot of the other features are present here. There's no 3D panner in the master. This project has been saved. We've built it. I've exported the GUIDs, so everything is ready to go, and I'll jump right back over into Unity, and we can start working with this. Well, the first thing that's important to note if we're going to do this is that we need to have some sort of event that allows us to tie the sound to that event when it happens. And if we look at the PlayerController script, there's really nothing in here that allows us to do that. There's no way to capture these wall collision events. However, we do have that with the cubes. Every time our sphere runs over one of the cubes, the cube disappears, we hear a sound. Well, that's similar to what we need to do with the wall. So we can take that code, copy it, modify it to do what it is that we want to do right now. Switch back to Unity and let's take a closer look. Each of these cubes is a prefab. You can see that they're all listed here as pickup and they're listed in blue as a prefab. And one of the features about these that's really important, over here in the box collider physics component, this option for isTrigger is checked. Now if I select one of our walls, we can see that isTrigger is not checked. So let me go ahead, hold down the Shift key, select all 4 walls, and then toggle isTrigger to on. We'll save it and run it in Unity. Move towards a wall, and oh, look at that. Our sphere just goes flying off the edge of the world. That's not working. At least it's not working partly. The reason why is that Unity will not allow objects with isTrigger toggled on to retain their collision physics. So those walls stop functioning as walls once I've turned isTrigger to on. But there's an easy way around this. I'm going to deselect isTrigger for the 4 walls, then highlight all of them, go up to the Edit menu, and choose Duplicate. And you'll see it will make a copy of each of the 4 walls from the tutorial. Those copies are currently selected, which is really helpful, and I will toggle isTrigger on for those 4 copies. You can save it, test it, do the same thing, and we stop. So now we have the behavior that we want, and that duplicate is there. It's in the exact same place as the original. It has isTrigger on and will allow us to do things with code. The others have isTrigger off and will retain the physics properties that we need. So we're much closer to where we need to be. However, we currently don't have any way to track these collisions in our code. And like I said earlier, we can take a closer look at what's happening with these pickups and use that as a means to do the same thing with the wall. So on closer look, yes, isTrigger is checked. But up here in the top of the inspector, each of these is tagged as a pickup. And that tag is important right here. code that came from Unity's Roll-a-Ball tutorial has the onTriggerEnter function. When a collision happens with a collider, it checks to see if that object or one of the objects in the collision is a pickup, or if its tag matches that label pickup. And if it is, then it does several things. From the tutorial, it made it disappear, it incremented the count, it updated the display of the count field, and then in an earlier tutorial in this series, we added this line that cued a random sound when that event happened. This is everything we need to do what we want to do with a wall sound. So we can make this happen. Let's begin with our duplicate walls. I'll select the north wall, make sure, isTrigger is on. Shift click, so I have 4 walls selected, north, south, east, west. And then I'll go up here to tag. And oh, well, there's a wall tag there. I must have left that in there for when I was getting ready for this lesson. It shouldn't be there. Let me show you how to create one. Generally, when you open this up, I'll just delete that wall tag, go back, recreate this. There we go. Okay, we go into tags and wall is not there. What I want to show you is that if you choose add tag, you can then type the name wall, since it won't be there in your file, and then go back and choose the 4 duplicates. These are the ones that have isTrigger selected, and choose wall, the wall tag that you just created. So here we can see north, untagged, and the same thing with south, east, west, no tag there. But we get to the east duplicate, and it has wall, as does west, south, and north. Fantastic. So we'll save that. And now we have 4 duplicate walls that are triggers, and they have their tag in place. With all of that ready, we can switch back to MonoDevelop and add the code that we need in order to get our collisions to be recognized by the game and tie a sound event to them. So as I've done with these other tutorials in the series, I'm copying and pasting my code from another place just so you don't have to watch me type it out. I'm not the fastest typist, and it would be painfully boring if you had to watch me type this code. This is the duplicate of what was there below. We check to see if on a trigger enter collision the tag equals wall. And if it does, we want to play a sound. The sound behavior that we had set up earlier was a one-shot sound. It was similar to what we used for some of the other events in the game. So I'm going to paste a one-shot event sound cue here. You can see that the event :/wall hit exactly matches wall-hit that we have here in FMOD. So those things line up and should agree. I'll save what I've done here in MonoDevelop, move back to Unity, which takes a second or so to think about the code. I don't see any errors down here at the bottom, which is a good sign. Test the game and crash into a wall. Aha! Yes, and we get an impact sound. And we'll get this sound for every single wall that we bump into. Now, one thing that you may notice listening to this is that it's the same sound every time. This is one of the problems, or not really problem, but one of our criticisms of the earlier sound design that we did. In that, if we were playing this game in the physical world, we would expect the impact sound to be different. So if the ball bumped into the wall and it was moving softly, like it was right there, it would make a soft sound, whereas if it was going really fast, we'd want a harder impact sound. Well, fortunately, FMOD allows us to do this, and it's really pretty easy. And that's what we'll do in the next part of this lesson. Now, if we were playing this game in the physical world, we'd really expect to hear something different, something less perfect, less consistent. We get the same impact every single time. And we can simulate that by linking FMOD parameters to different conditions in our Unity game. So in this part of the lesson, we'll use the velocity of the ball to determine which impact sound should be heard so that each collision sounds different at the different speeds. Well, here in our FMOD project, there's a behavior called wall-hit-vel, wall hit velocity, and its timeline has nothing. But next to the timeline, there's another tab, sound velocity, or SNDVEL. And you can see that in this timeline, it has 0 through 20 different values, and then along it, there's 5 different sound events that are dropped there. This one is done, and this one is ready to go. If I play the event, you can hear that first sound, but I can use this little pot to change the value of sound velocity. And every time it gets to a different value, you can see how the playback head moves along the timeline. It's playing a different sound. I called this playback head. It's really not a playback head. This is one of the things about FMOD that can take beginners a little time to wrap their head around. Is, we look at a timeline and we think, oh, this looks like Logic, this looks like Pro Tools or any other audio software that you may have used. But when you're dealing with parameters like this, it's not a timeline in that sense. At this point, we're still looking at something from left to right, but the range of values isn't temporal. It has to do with these different parameters, in this case, velocity. So let me show you how I created this. I'm going to go ahead and just create another one in here so you can see what it looks like. I'm inside the event. Like I said earlier, the timeline is empty, but up here, there's the sound velocity that I created, and then there's a tab with the plus sign. I can click that one and choose Add Parameter. I'm going to give this one the name Tutorial since we're doing this for the lesson, and I have to set values. Well, starting at 0 makes sense given the way that Unity tracks our velocity. And I'm going to set the maximum to 20. Now the reason I know it's 20 is because I spent some time working with this project and was able to look at the velocity values and see that it really never got above 20. It really tends to, I never really even saw it got much faster than 17 or 18, but I thought 20 is probably safe. And if you take a look at the description for this video, you'll see in the full download for the Unity project, I have some additional code that's not up on the screen for any of these tutorials that allows you to track those values and actually prints them out in GUI text on the screen in Unity so you can see what the velocity value is, and there's a couple other things that I put in there as well. Well, now that I have the parameter and I have values 0 through 20 set, we can add some sounds here. Choose Window and Audio Bin, and it opens up all the sounds that I created for this project. The sounds are the series of PU-click sounds, and I have 0, 1, 2, 3, 4. These are different variations I made from an original PU-click sound. And I'm going to bring these in and drop them on the timeline. Now, the names and the order in which they go has no correlation whatsoever. It had more to do with the order in which I made them than anything else. But in order to make them, I started with an initial sound and then just made a little change in pitch, a little change in EQ for each one. Creating these kinds of sounds in a game development environment, yes, they're all different impact sounds and you want them to be different so a soft hit is more gentle. A forceful hit has more impact to it. But at the same time, at least in a situation like this where I'm trying to do something more like physical reality and acoustics that we hear in our world, they can't really be too different. So just a subtle change of pitch and EQ was all it really took to make these work right. For this lesson, I found that it's best to just space them out evenly. So I have 5 sounds, values of 0 through 20. So I give them each a span of 4 here in this timeline. And that works well. For another application, you may find that you need to use uneven spacing. It really just depends upon the event and the sounds and the gameplay, and every situation is going to be different. So that's the event. I can save the project, play. It happened to start here with tutorial at 0, so it's playing that first click. But it works exactly the same way that the other one did. Good. All right, so that's how you can create that sort of sound event for yourself. That's how you add a parameter. We don't need this one for the rest of the lesson, so I'm going to go ahead and get rid of it. Save the project, and as always, when you're finished with something like this, you want to make sure that you build. You want to make sure that you export your GUIDs, and once you've done that, you are all set and ready to go in Unity. PlayerController script is where we need to begin here. So I'll open that up, and here we are looking at it in MonoDevelop. Script is where we left off with the last lesson, so it's playing one sound, the same sound for every impact, and we need to make some changes in order to implement the new behavior that we just created in FMOD. First thing I'm going to do is create a new variable, and I'm going to put it up here at the top with all the other new variables. This is a private variable. There's no need to access this in Unity, so private variable is all we need. It's going to be a float because we get lots of floating point numbers when we're looking at velocity, and I called it pvel, P capital V-E-L. Player velocity is the way that I was thinking of that, because that's what we need to track. How fast is that player sphere moving across the plane? Now, we'll make some of the code that cuts across both of these applications. The first thing we need to do that's related to FMOD is to declare another private variable, and you can see that this is something that's related to FMOD. This creates, or it lets Unity know that there is a parameter that we're using in FMOD, and you'll see that the name sound velocity, or SND capital VEL, is exactly what we created when I made that behavior in FMOD just a few minutes ago. We also need a way to identify the event of a wall collision. So I'll create another private variable. This is also something that we're tying to FMOD. So it's an event instance, and I'm calling this one wall hit for obvious reasons. With those few things in place, we can start to connect the rest of this code with what we were doing earlier in FMOD. The next line that we need will actually replace the line that we had earlier. Here in my code, it's line 54. This was the play one shot for the wall hit. We're not going to play a one shot anymore. We're going to do something different, and it's going to look just like this. Wall hit is that event that we just created, and we say that when that happens, we want FMOD Studio System to look at an event that's in all of our FMOD assets called wall-hit-vel. And that's the same event that we were working with in FMOD earlier. So this effectively connects code that we just created in Unity with an event that we authored in FMOD earlier. Now, the next thing that we need, this is a big chunk of code that I'm going to copy and paste from another source. And I'm going to drop that in right below it. Yeah, like I said, it's a big chunk of code. And in short, what this does is it makes sure that sound velocity, or that parameter, SNDVEL, will always have a value. Or in short, make sure that it's not going to be null ever. If you remember, that parameter starts in FMOD at 0, it goes to 20, it always has some sort of numeric value tied to it, and if Unity sends something other than that, there's going to be some sort of error. So this helps make sure that that won't be the case. And then lastly, we need to take 2 more steps in order to get all of this stuff working. 2 lines of code. I'll add the first one right here. And that says that the value for sound velocity, or the value of that parameter that exists in FMOD, should be set based on the current value, pvel, or player velocity, in Unity. So it's looking at what value comes from our player and how it should translate that into what FMOD is going to play back. And as I typed that, I remembered, oh yeah, there's something that I forgot to include earlier. I missed the line that said, that actually retrieved that player velocity. The first variable we created was that value, but we haven't actually assigned it. So let me go back and grab another chunk of code. And this one I'm going to put in the fixed update function. If you did the Unity Rollerball tutorial, you know that fixed update is a way to make updates for any sort of game event that requires physics. Rolling the ball is definitely one of those. And this line that I've just pasted assigns a new value, or it updates a value for pvel throughout the time that the game is being played. And it's looking at the rigid body physics that are attached to the game object, and in order to get this as a usable float value, we have to retrieve both the velocity and the magnitude. And those two elements will allow the value that we save in pvel to be usable for Unity. So pvel is going to get its data there. It's transferred to our parameter coming from FMOD right there. And then lastly, the line of code that without this nothing would happen, we actually need to play the sound. So we use the start function for our wall hit event that we created earlier. And that is everything that we need to do in mono development. I'm not seeing any red, which is good. It means we don't have any errors here. So I'll save this and move back to Unity. Let it think about that for a while, and everything looks good in Unity. Test the game. And right away, I run to the corner and we get 2 different values because I hit each of those corner walls at a different velocity. Let's do a really soft hit here. It takes a while to get there. And then we'll rush to the other wall. And rush to another wall. Yeah, we hit the corner so we get another 2 values so we can hear it's really working. And this is exactly the sort of thing that you really want to do with your games. When it comes to making sense of the game world sound is one of the best things that you can use to do that. And different sounds provide different kinds of feedback, and it lets the player know more about the game world that they're in. So I hope that this was really helpful. I've got one more lesson planned, and we'll do something that's related to this, but we'll look at it in a slightly different way.